material, geopolymer, whatever material you're using. And this, you've extended the life of your house by 10, 15, 20 times. It's huge. Think of all the generations after you owning your house without having to pay anything. They just get your house and they keep it and their kids keep it and their kids keep it. That means you're not paying rent all of the time. You're not having to do huge renovations. You're not having to rebuild. It's huge. It's a life changer for most people in any country. And that's really the direction we're trying to go. All right, you guys can take a look at that. It's cheaper.
Surprisingly, we're still in Iron Age. Surprisingly, we're still in Iron Age.
Yeah, we are. We really are. This stuff is cheaper than steel or iron, much cheaper. And much easier to work with. I mean, that's incredible. That's just unbelievable.
Yes, people, welcome for everybody tuning in right now. Gordon Simpson, G-Man Simpson, all the way in Manchester. We've got a business called Camhirst Robots. I'm going to show you how we're going to be building houses within 72 hours globally, and obviously what is going to benefit the people watching as well. So this is a business opportunity anyone can get involved in as well, so keep posted. But I'm going to be showing you what we're doing here. We're just going to be putting some of the concrete into here and laying it on the floor and showing you how it's all set up. We've got the workers out here as well, and we're just doing some demonstrations also. These are actual robots devices, the shell, the chassis, of which obviously we installed in different countries as well, and then we'll attach the robot, which obviously does the concrete laying. As you already know, building houses normally takes months, sometimes even years, and if the contractors are shit, it'll be even more than years. So here we are. 72 hours, we'll be laying foundations in different countries around the world. Obviously, we've got loads of different contracts in Africa at this moment in time, which are all being signed out with the unions. And this is the concrete. I would say this is a demonstration version. Just putting up different layers. But you can see over here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different layers what was on there, just an example, but this will be built all the way up to the height what's required for the buildings itself. These machines can also do hotels and villas and everything else as well. Obviously they will take a little bit longer, but we're only talking about 5 to 6 to 7 days depending on the size requirements. But a standard house, 2 bedroom, 3 bedroom, that will be 72 hours, between 48 to 72 hours itself. And all training will be given to anybody else who's taking these out also. As you can imagine with a house, if you've got this going down and round in a circle, that means there's no weakest links, or no weakest links means it's more durable. So earthquakes, hurricanes, everything else, they'll still be around for a long period of time also. Compared to when you're using steel and breeze blocks and obviously the cracks, that's when you've got a weakest link in your system. So that was just a little intro right there. This is what we're doing. Thank you for watching as you're tuning in, and we're just getting everything set up right now.
The things that I do, you come up with a much stronger concrete and a much better concrete, and a concrete that lasts much longer, simply because of the basis of it, which is really technical, because sand is more of a quartz type substance, and lava or magna or volcanic dust or whatever it is doesn't have Google it. The difference between using sand for something and using volcanic powder or volcanic rock.
So this is the wonderful CEO as well. We've got Adam right here, just live on TikTok. So real people, real business, and that's opportunities there. Just making some adjustments on here so we can show you how it actually works. Concrete is already being mixed, ready to just line it in here, just editing. Who's in the construction field? Who's an investor? Who's wanting to have houses in the next couple of years as well? Give me a shout.
They were coming up with a way to make hydraulic concrete, which you can dry underwater, which is going to last for thousands of years. They didn't realize that because they were just finding a solution to the problem. Nowadays, we do realize that.
If you're in the construction world, I know that your steel will be heavier than this.
A local place here.
Look at that.
Most of
This would normally be a couple of pounds. Lifted that with one hand right there.
Into a flower bed. There's a lot of people that buy volcanic powder for a flower bed because it soaks up the nourishment and moisture and everything, and it's a good substance to put into plants and everything because there's actually minerals and whatever stored up in the concrete itself. But this right here is a big time game changer as well. We use this as well as some sand.
Just giving you some product knowledge about the concrete what we're using, and the concrete will be used differently in different countries as well due to the materials that are available. As you already know, it's hard to get things shipped out, so they'll be doing a lot of manufacturing on sites in different countries, making sure we've got the right equipment and materials available as well. Henry Ford cars, yeah? The way it built.
No. You like Henry Ford of cement.
Oh.
Henry Ford didn't design it.
No. I'm just talking. So
you're telling him the right thing. I know where you're going with it. All right, my brother. All right, my brother. Say no more.
There is so much more to it. I mean, what you need to understand is...
I know, exactly.
Like I said, things take time. And research and development obviously took the most time out of anything up to where we got to now. Now that robot was manufactured in collaboration with our strategic partners in America, and there's a lot of specialists that have come together to build that robot. A lot of talented people came together to get it right, because the biggest problem you have with our competitors is that their machines are not affordable, their machines are not scalable. They're not a cost-effective or easy solution. So it's like me saying I've got a car, which is for the ordinary person. If the car is $100,000, that is not a car for the ordinary person. So our robots are approximately half the price of most of our competitors. But more than that, the biggest challenge we've got, you see like with our competitors, they have a four-legged gantry system. Meaning they have huge posts which go all the way to the floor, and those robots are very heavy. Now the four-legged gantry system needs huge concrete feet for it to be bolted on. Now concrete, normal concrete can take up to 28 days to cure, to dry. Yeah, so that in itself, I mean, if you explain about the biggest problem with the four-legged gantry system in the concrete.
Yeah, a lot of these companies, especially the gantries with these huge robots, when they come in, go tell these guys they don't need to be doing anything here. If they don't work here, they don't need to be doing anything. If I want new people, I'm employed.
One question while you're there. How long does this concrete take to dry?
It depends on which one it is. There's
different ones, yeah? Okay.
For a gantry system, there's 4 feet, and the feet are these big blocks. They're huge, and they weigh 2,800 pounds each, and they cast them, and then they put the bolts in them. They have to wait 28 days for them to harden and cure, and then they can bring in these huge cranes and drop the legs down, these things, and bolt them in, and then they can start printing. And then they will tell you, and even right on their website, we can print a 3-family house in 3 days. After you've waited the 28 days for the thing to cure, the 3 days for them to, or 2 days for them to set it up and everything. So after the 30 days are over with, they can then print in 3 days. That doesn't sound very realistic or truthful to me. Nothing against these guys. I have a very, very, very high respect for all of them in the industry. I know most of them. They're incredible what they're doing. It's amazing what every one of them are doing. It's just we're doing it a different way. I'm trying to get as light as we possibly can, to do things as fast as we possibly can, so we can really go international with it. That's basically the difference.
Almost ready to start laying down this concrete.
But nothing against what they're doing. They have changed construction. So I can't knock any of them. I'm just saying what we're doing is a lot faster and a lot lighter and a lot smaller. And that's the big difference.
I think one of the key things is to understand what Ed is saying is They don't be honest about how long it takes them to print.
I wasn't actually going to say that. I was going to say, I'm telling you the story, you figure it out. It takes me 30 days to set up the robot, and I'm telling you I could print a house in 3 days. Tell me what part of the story doesn't seem to add up to you.
Building houses in 3 days, 72 hours.
You're sitting there for 3 hours going, what 5 minutes was he talking about? You know.
I talk about the ABB ones.
Yeah,
What's the downside of them?
the first robot that I used, we kind of thought we were going to reinvent the robot. Stupid idea. Cost us a ton of money, and we realized they're actually doing pretty well with the robots they've been doing for the last 50, 60 years. The ABB robot or the Fuka robot, either one of the two, are basically robots that are used in the auto industry. It's just an arm. Most of the time it's a 6-axis system. So you have your up, down, right, left axis, and then your forward, backwards axis. And we used those for a system we were doing, which turned out to be about as super an idea as the first one was, a little bit better. But we also realized, first of all, the arm's not going to be long enough to be able to really print a house. Second of all, if you're going to be printing other parts of the house, you've got to move the whole robot. Natalie at Apple can sing a super song about that. She's the head of Apple. I got great respect for her. They just got $660 billion investment. I'm very proud of her. And they built a house in Dubai where they moved the robot. I don't know, 220 times. Crazy stuff. And it took years.
Well, it did come out the bottom looking like doo-doo. Well, let's have a poo-poo. What's going on here in the construction world? Soon ready.
Had a thing you can talk on with the modern iPhones or whatever phone you're using. If you don't have a real phone, iPhone, sorry. There's little Apple advertising on Big Apple person. And that's the problem with the game. It's very, very big, and it needs to be reduced, which is what we've done. This is more Caucasian. This is two-legged. Gantry is anything basically that has legs. And most of the time when people say gantry, they automatically think 4 legs. It's not actually true. Gantry is anything that has legs. But this is a 2-leg, which would be a Caucasian system. With the arm system, you're very reduced in the length that you can print, and then you've got to move the robot physically. With this, we can lay down track from here to wherever, Brooklyn. If like Cobalt or one of these, say Cobalt for instance, if they were going to extend their robot out, it would cost about $330,000 for every 20 meters. And it would take 28 days to do an extension on it. Ours costs, well this is not, it's got an L thing underneath this which comes up where what's called the rack, the gear thing, that's the gear, which is called the rack, and you have the round gear, which is called the pinion, which is like a rack and pinion steering, which is on every car. Once the L thing is on here, these things we can extend 20 meters. We can probably extend for, instead of $330,000 to $320,000, $330,000, we're looking at probably less than $1,000. So we're only about 300 times cheaper than they are. Say 320 times cheaper than they are.
The sarcasm!
Instead of 28 days, we're looking at probably 15 minutes, 20 minutes, and we're able to set up. So we're like 300
Speed.
times cheaper than they are.
Cheap and
about
cost effective.
3,000 times faster than they are. So there's a lot of reasons why you can get a little better. Plus you could put this in a little transporter, and you're going to need these huge trucks and cranes and all of this stuff with the stuff they're building. You don't need any of that. You need this. You need, I would use electric to do all this and put these things in because it's a lot faster. You can throw it in a transporter, you can move it to the site, and you can put it together in about 2 or 3 hours. I'm going to get it down fast.
So we're almost ready.
Let's get in.
can get it in. This is a temporary demonstration.
There's a mixer pot. Pipes go to the back of this.
Oh, and it keeps on following it through as it's being fed, yeah? Alright. It just keeps on hydraulically pushes it straight into it.
Silo goes into the mixer pot. The mixer pot feeds it into there.
Yeah.
You don't need to do
No.
huge amounts
Just
of
for it.
cement.
Only doing small.
You guys ready? Sabo, are you ready?
Sabo says he's ready.
Yeah. So we can put this on stack.
It's from the corner.
That's why it's going to like episode. Because there's nobody doing There's nobody doing high rises ever. And with this, we can do high rises. That's another thing. She asked a question. How many stories can you build? And like that depends on gravity. 300, 400, depending on gravity. Because this thing is so light, you can put it on scaffolds and run it up the building. So you can do it like that.
So you could build a tower, couldn't you?
What I said to you, villas, hotels, skyscrapers.
So would there be, what about the land?
So
Would there need to
we're
be-
going
Foundation, village,
to print now so you guys can see it.
And then you build on top of the foundation. So you need to be level as normal, and then this is just the shell of the house.
Yeah.
Stay past this point. Past this point where this robot is. Don't trip over. Just stay past this point. And don't go too close to that because the robot moves and whoever's handbag's that's going to get squashed.
It's not mine. I'll let it one later.
All right, let's get building. Over that side, whoever it is there, perfect.
I'm going to take some as well, so you're going to be
Yeah, no, wherever you want to be. Where, Travis? You tell me where you're standing. There, yeah? Good.
Can you just go and stand that corner over there?
This is obviously a cement formula. They're going to test it for into the carbon, and then they're going to do a test print. We've handballed it in because it's only a small print test. Behind you, all you can see a white mixer. That MTech thing. There's a silo. Cement goes into it. When you do it properly, you're going to build a bigger wall. Cement goes inside the silo. That goes into the mixer. The mixer will pump it. There's a part there at the back of the extruder where you let it goes into. So there could be a continuous feed from the silo mixer into there. So it's just a small test. We've handled the cement in there today just to show you. So this robot, the way it works, you'll see it obviously doing the test here. So it goes along the extruder to building a wall. The builder will switch up to whatever point it's been programmed to go to. And from that point, the whole robot, because it's on tracks, will move and it gets printed. Whatever length the track is, or whatever is programmed to go, that's where it's stop. Then that extruder will go along this path, again, keep printing, get to the point where it's programmed to stop, and the whole robot on the tracks will keep printing, the whole robot will move. So you'll see a little bit of that happening now, where it will move along, the extruder will move along, whatever it's been programmed to do, and then the robot will move, continue printing, along the bar, back again. So this is a fantastic way to do it, because unlike the four-legged gantry system, you can only print inside the four legs. Because you can't, and that's quite restricted. You all heard about Trump wanting to build a wall between Mexico and the USA. This robot can build that wall. I won't recommend it because we like it in Mexico. Yeah? But because it's on track, it will keep building as far as you want. And that's the unique design. And the thing is that we made it scalable, we made it cost effective, we made it so it can be mobile, we made it transportable. And that is the main reason why 3D concrete printing hasn't gone mainstream. Ed was slightly busy. We're talking about the Henry Ford example. Before Henry Ford started mass produced cars, there's only 5,000 cars. 5,000 cars. And the 5,000 cars could only the very rich could afford them. Only the very rich could afford them. Now he came in and produced over 20 million cars. Yeah? There's no problem. Health and safety first, save my life.
How many layers then?
I'm going to try to save it and then I'll probably try to share it. But the problem is when I try to share it, it's the size of the file. Yeah. I'm going to try to put them on YouTube. So what I'll try to do is a normal video with a facial lines on TikTok. TikTok can save it, but it's always too big. Even if I was to WhatsApp it, you're going to get a piece of, you get where I'm coming from. If you got the invite to come up.
No, I'm brand new to this, so obviously
It's coming to us,
sidelines because I've got quite a lot. I like BlackRock right here. Top tier investors is
so it speaks for itself. That's the benefit I like about it. It speaks for itself. You have to talk. This is why I love people.
Do you? It's very convincing when you actually see yourself.
It's about everybody putting a piece in buying a house and eventually the share of a rent and same thing again. It's not about you.
I'm thinking possibly only one.
You're renting out it's a team. You're renting out.
Can do it together. That's what we're talking about, isn't it?
It doesn't matter different type of the team is, as long as there's a place that's $250 in the pot and we'll get dividends. Guess what? That's what we're already giving you. So there you want to go. But everything you just thought about what is already been in place with the system that I've told you. There's 3 different sites working. Camhirst is this one. You get different in some.
Either way. Oh yes.
Yes, please. Right, so we're doing it now. We're just preparing the CAD system, getting it all lined up, and obviously seeing what we're going to be designing, just testing to make sure it's right in position. You don't want to build a house in the wrong location and getting the height set. So patience, and we're ready to go. Everybody's all lined up here. Say Camhirst Robots. So if you guys are watching, remember say Gordon Simpson told you first. Concept. Oh, you can see now. Sorry.
Now I did that to lower the first level. I did it flat on purpose. I kept it very close to the bottom so it would spread out because it gives you a wider base and therefore it's easier to print on top of. Because I told him I'm going to do the first layer flat. And then when I looked at it, I said, okay, that's really flat. But it's better to overdo that than it is to have it really thin at the bottom because anything will just fall off of it.
Stress.
As you can see, and then the second layer will be a little bit flatter too because it's not as high. And while it's running, you not only have to calculate out what you're printing here, you have to calculate each time it goes up like this right here. The z-axis is going up like you say turning. You have to calculate that because if you're going up too much each time, then the extruder will start pulling the concrete and then it will just fall over. So you have to press it just a little tiny bit to get it to work. We've actually got some new extruders in there, I'll show you in just a minute, which are much better than what we're using right here. But I've been working on that, so I haven't really had time to test them yet. They're much better than what we have here. We have a bunch of new ones in there, which I'll show you. I think they're really cool. Nerdy shit. When you see them, they're really shiny. Shiny objects.
So imagine just leaving this machine running and not needing loads of staff to do all of this. It could be raining outside and you're still developing your business. That's what we're about to see right here. 72 hours to build a house, 2-story, 3-story house, or bedroom, sorry. All good, but you can build this as high as you want as well. So this can be done on any hotels, skyscrapers, whatever you've got, you name it. Even if it's just a small project or even a large one, this can all be done. Railway stations, bus stations, schools, whatever you're needing, we can get it done. So like what you asked me already, the longer the rails go down, the farther it is, and obviously the position to all of that. So, Julie, schools, railway stations, petrol stations, whatever you're needing of that kind of, even if it's a toilet, even if that. Bigger project, smaller project, this still can be done in it. You've got the material.
Out the live? In the live?
Yeah. TikTok, I can save it and I can put it on every damn platform.
All the birds, one stone.
And Julie's a part of it too. There we go. There we go. Contact one of these guys, you know.
More pressure coming down. Or we can use.
Yeah. No envy, there's no green.
Relevant to smart contract. You know the thing. It changes people.
Yeah.
You can't change
Or
it.
this.
Yeah.
And then this. Now a bit larger. And that's the different ones that we can use. And you'll need different ones for different applications depending on what you're building.
pipe in the bag. You're gonna use it for big italic writing or the bold.
Yeah.
Why are you gonna waste time doing it with thin when you can do it big?
Yeah.
How come it's twisting a little?
Huh?
Is that the twisting a little bit?
No, it's too high.
It's too high on the
This
thing,
is what
yeah?
I mean. Because the concrete is sinking, because there's too much slump on it, this is too high. See? It's too far above the concrete. Because this concrete is slumping too much. And then you start getting something like this. But it looks pretty cool. Probably not what you want. You got a cool zigzag pattern going.
So yeah, what it did there was it showed us the errors of obviously if you was to put it too high on your building, it's going to cause this problem. This is why it's more precise with how he's doing it all the weather. So there's the correction.
Yeah.
Making sure it's the right size when you're developing. There's the issue. And that's part of your training.
Yeah. Yeah.
So
you need to be trained to do all
Yeah,
this.
yeah.
You couldn't just rock up.
So this is the reason why we're going to be having people trained from out the sources. Anyone who purchases this, you'll be getting fully trained on how to use it and obviously get your levels correct, so you don't have these problems at any stage.
Real quick, you may think I like it when you see us doing it perfect. Actually,
I want to see a problem.
I like it when you see a problem. So I can explain what the problem is.
Here we go. This is what I'm saying to him, yeah? I've come here to see problems. I didn't see you to see it smooth.
The problem is the concrete, as you can see, it's getting wider and wider and wider, which means there's too much moisture in there. Which I can say is all solid fault. I've done the same thing. You can look at some of my stuff within the corner. We all do it. It just happens. You know, sometimes you get it right, sometimes you don't. We're testing mixtures right now. Sabo did the one over there where we did 10. He did the first 5, I did the top 5, because everybody left, and I was like, I'm going to put it on top of this stuff just for the hell of it. And it looks terrible, but it is 10 layers. With something this wide, that's almost impossible to do. But in this case, it's a little bit too moist. Therefore, while it was printing, the concrete kept lowering. And the more layers you get, the deeper it gets. Now, you can print with concrete with too much moisture, but what you have to do is you would have to say, okay, on the first layer, I'm going up 0.5. On the next layer, I'm going up 0.48. On the next layer, I'm going up 0.46. On the next layer, I'm going up, then you'd have to take a jump, 4.0. On the next layer, you'd have to reduce how much it's going up for the next layer on each layer to be able to make up for whatever you're losing because the concrete is basically just sinking down. So that's basically what you would have to do this. Of course, with anything this wide, spreading out, you're not going to be able to use it anyway. But it's just a test. It's just a test to show the way that the robot works, the way that it prints. And I mean, we were in there eating pizza and all this stuff. We kind of came over here and mixed the stuff up really quick while I was talking and not watching what they were doing. And that's weird. It shit happens.
Is there a set amount that you're supposed to put in? So obviously there's the mix, but is it going to be the people mixing it on the site? So will the computer calculate what the proportions of how it's supposed to be mixed to make it so that you don't get that as much?
Well, the thing is, the computer can calculate how much you need to mix, but somebody's got to mix it.
So it's down
unless you have a computer-controlled mixer. And a computer-controlled mixer would then have to have silos for whatever material you need, and there would have to be valves for the silos to let certain amounts out. It would all have to be calculated, which we have actually done on a geopolymer machine, which has over 1,000 different formulas in it. Well, actually, we haven't done it. Renka, the people we work with have done it. Can we do something like that? Sure. Again, I'm working on that. I'm working on the next thing, the next thing, but we will get around to that. It's definitely on our list.
Yeah.
That we will have actually a robotic system. We want to, again, make it as simple as possible so you don't have to spend hundreds of thousands to be able to have computer activated valve system to draw out whatever materials you want. You could do it with a system like that. It's just very complicated and it'll cost a lot of money. You're much better off if you sit. I've got in there a bunch of different meters where I can measure the humidity, the temperature, and all of that. Because as the humidity changes, the moisture changes, so you're going to need less water in there. Today the humidity is very, very
Weathering.
high because it's been raining. Yeah. If you had printed this 2 days ago, it would have been perfect. So it's, you can really say that would have been perfect on Tuesday.
Yeah.
But it's not perfect on Sunday.
Yeah.
On Wednesday, it would have been a little bit iffy. Thursday, oh, it would probably been too dry.
Yeah.
So it really depends, and you've got to have these meters. I've got them in the office. I can show you in a minute if you want to see it. And it basically measures the humidity, the temperature, the CO2 in the air. And then you have to use that information plus the materials. Don't push that around, please. Just don't let it go off the tracks. And you have to use that to basically calculate what you're going to do. I'll show you the meter, and then we need to take the concrete out of it.
Okay.
The interesting thing is, believe it or not, it only takes, for a bag of this material, only takes 100 ml of water to make 1 oil change. So I tried that because I thought the temperature was going to be a little bit. I've used an accelerator on this, tried to sort of tighten it, but it hasn't worked.
Yeah.
So, and all I did is change the moisture content to about 0.1. Instead of 2.4, I put 2.5.
Right. Okay.
Just to make it flow a little
So
bit.
it's very small amount difference.
Very, very small amount.
Yeah.
Depends on the materials you put in.
Yeah.
So, yeah.
That's the tricky part, isn't it? To get that mix
It
right.
is.
Yeah.
It is. If I dried it a bit more, I would have just stood up and fallen
Yeah.
to one thing.
Yeah.
It's a matter of calculating how much you need. I mean, a small test daily before you start printing.
Yeah.
That's the way to do it. Yeah.
For each climate, everything else, etc. Yeah.
When you're printing at that time and say the climate starts to shift and change as it's happening, as you print, don't think that will make much change. Not much of a difference.
Not in a day unless it's raining.
Right, unless it comes down.
So in
Yeah.
every country would be a different climate with all the changes, so which country you're making it in would
That's
make
right,
a difference a lot.
That's why we're trying to think of
Bespoke.
where this machine goes in. We want to go in and make sure the materials are proportioned right. And for each country, we tell you roughly how much water you need. So it'll be on the bag. It'll be on the bag to say 2.5,
Hi everyone,
2.3,
you will all follow me this way.
something like that.
Okay, thank you.
Something else to do.
This is what I was trying to say to you earlier, but now you understand it.
Yeah,
Now you
yeah.
makes it in the concept,
Yeah,
yeah?
I want to know what the problem is. So
Yeah. Got the chart first. Eddie, showing yours quick.
Oh yeah,
Sorry.
CO2 detector, wherever that is.
So these are just some of the equipment we use. This right here will measure the rotations of this right here. It has a laser on it, which you can see the laser pointing right there.
Okay.
It will tell you how many revolutions per minute the extruder is turning, so you can use that as a calculation and make sure you got it set it on the right
Okay.
revolutions per minute. Then I've got the heat sensor. It's infrared. And what it will do is it will show. You can see that the concrete is actually hot.
Yeah. Okay. Yeah.
All right.
Yeah.
Yeah.
You can see the concrete is actually losing heat.
Yeah.
because of this, and it will tell you if I put it on there, it will tell you the concrete right now is at about 20 degrees.
Okay.
Although the room is probably only about 10 degrees.
I can feel the cold. Can feel the cold.
I'm already a cold person.
It's going to tell you that the concrete will be close to 20 degrees.
So the primary problem is the mix on the time.
The primary problem is this where the training is. And as
Yeah.
I said right there, he rushed it and
Yeah.
he was eating.
Yeah.
And he just let somebody else do it.
Yeah.
He wouldn't let somebody else do your house.
No. Honestly.
Through different mixtures, because you can change the mixtures using this. You can change your mixtures to make the
Instagram
concrete
about
act
snap
different
is
ways.
that?
Using accelerators.
Look how many views on TikTok.
I can't find the other meter. I don't know where
So
it is. It's got a
if they're building where it's warm and then during the
No,
season
thank you
it
for
gets
that.
colder again, so
It's,
how would they...
interesting. Yeah.
So that's it, guys.
Yeah, but if
Yeah.
it's built and done
Thank
and
you.
dusted, and then in winter it's going to be a different temperature to where it was when they built it.
Because it's settled. This is in the manufacturing
Okay, so once
stage.
it's settled, doesn't
Yeah,
matter.
it's drying. It's the installation in the drying stages. The drying stage is responsible. It would have been the 20 days to dry. So in between the cold press and the hot pressure, that would still need to set. That is still hot. And the other still be hot when it's cool. Once it's cool, then it needs to set. And obviously it's still going to break. Yeah.
Okay guys, so that is a little demonstration right there. I'm going to save some of my battery and obviously take some pictures and network with some of these guys in here. As I said, my name is Gordon Simpson. I'm all the way in Manchester at the moment in time, looking for more people and know more about this business. People around the world, obviously interested in investments. That's the key factor I'm looking at the moment, and who want to help solve the housing crises around the world as well. If you're already in the construction field, give us a shout, because we're definitely want to speak to you. But I want to talk to any of you guys watching this video right now, yeah? So as I said, thank you for watching. Camhirst Robots, letting you know about the 2024. Boom! Bye.